It looks like number 20 is going to be a L'Hopital's rule problem. Whenever we do L'Hopital's rule, we have to have the form 0 over 0, or infinity over infinity, or minus infinity over positive infinity, or something like that. We need either a 0 over 0 or some kind of infinity over another kind of infinity. Let's see if that's true here. Why don't we let x be equal to pi in the denominator and see what we get. When we do that, we get pi minus pi times the sine of pi. Well, pi minus pi is 0, and the sine of pi is also 0, so 0 times 0, we get 0. So the top is 0, and if we let x equals pi in the bottom, in the denominator, oh, sorry, I should have said numerator here. Numerator. So when we let x equal pi in the numerator, we get 0. Why don't we let x equal pi in the denominator now and see what we get? We get 1 plus cos pi, which is 1 plus negative 1, which is also 0. So this limit has the form 0 over 0. So that means we may apply L'Hopital's rule. It's always good to justify the reason you're allowed to use L'Hopital's rule. If the limit doesn't have the form 0 over 0 or plus or minus infinity over plus or minus infinity, you cannot use L'Hopital's rule and you'll get wrong answers. So let's apply the rule and see what we get. I'll just copy down the question first. So the limit as x goes to pi of x minus pi times sine x over 1 plus cos x. So we're going to apply L'Hopital's rule, and that just means we do the derivative of the top and the derivative of the bottom separately, and the limit that we get will actually be the same value as the original limit. Now remember, L'Hopital's rule has nothing to do with quotient rule. Even though this is a quotient, we are not applying quotient rule here. We are just doing the derivative of the top, the numerator separately, and then the derivative of the bottom, the denominator separately as well. So let's do that. Why don't we do the derivative of the bottom first? The derivative of the bottom is 0 plus minus sine x, which is just minus sine x. And if I do the derivative of the top, I have to use product rule. The derivative of x minus pi is 1 minus 0, so just 1, times sine x left alone, plus x minus pi left alone, times the derivative of sine x, which is cos x. Now notice if I let x be equal to pi in here, we get 0 over 0 again, right? So that means we're allowed to use, if I put 0 in, do you agree with me? Sine of 0 is 0, or sorry, sine of pi is 0, and pi minus pi is 0, so we have 0 plus 0 on the top, and the bottom is sine pi, which is also 0. So we do have the 0 over 0 form again, so we may apply L'Hopital's rule one more time, right? Why don't I just cheat a little bit and grab this and put it there. And so let's apply it one more time. Often you have to apply L'Hopital's rule more than once, so that's something to be expected. And the nice thing is, when I do the L'Hopital's rule now, the derivative of minus sine x is minus cos x, right? And although you cannot put, if I put x equals pi in here, I get 0, right? That means that you can't do the limit that way. But here, when I put x equals pi in, I get a non-zero number, right? So cos of pi is negative 1. And that means on the next step here, I'm going to be done. Because whatever I get on the top, I'm going to have to do the derivative of this still, but whatever I get, I'm just going to put pi in everywhere, and that'll be my final answer. And just to emphasize, the reason I know that I'm going to be able to stop after this next step, I won't have to apply L'Hopital's rule again. The reason I know that is because when I put pi in here, I get a non-zero number now. So let's see here. When I do the derivative of this to complete our L'Hopital's rule here, derivative of sine is cosine. To do the derivative of this is a product, so we'll have to use product rule. The derivative of x minus pi is just 1 times cos x left alone plus x minus pi left alone times the derivative of cosine, which is minus sine x. And now, like I said, I'm allowed to put pi in everywhere here. So I get cos pi plus another cos pi plus pi minus pi times minus sine pi all over minus cos pi. And that works out to what? Cos pi is -1. This is 0, and this is 0, so this is just 0. And this is minus of -1, right? So we have -2 over 1, which is -2. So there's our answer. Let's fill that in the spot. So just write -2. Here we don't have to write any sentence or any units because it's just a pure math problem. All right, that completes that one. And by the way, you can check this answer. How do you check this answer? Well, we know pi is about 3.1415, whatever. Why don't we put 3.14 in this function and see what kind of number we get? It should be close to -2, right? Remember, 3.14 is not equal to pi. It's close to pi, but it's not exactly that. So if I put 3.14 in my calculator, make sure your calculator is in radians, and I work that out, what do we get? 1 second. So I'm just putting I'm putting 3.1 in for x to see what I get. You know, when I put 3.14 in for x, which is pretty close to pi, this expression, this entire expression comes out to be 2 points. Wow, there's a lot of zeros. 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6 zeros. And then some junk. And, oh, sorry, there's a negative in front as well. So what that does, that convinces me that I do have the right answer. So when I put a number close to pi in, and I get a number so close to -2, I know for sure I've got the correct answer here. But by the way, using your calculator to get this answer, you'll get probably 0 points, right? You have to use a proper technique, which in this case is L'Hopital's rule, to arrive at that answer of -2. All right, so that was just a check, and I'm confident that's the right answer. So we can move on.